Okay, for the first part of our video, we're going to review the last section that we talked about in relation to concentration gradient. There's a couple different examples we can use that are going to support this. So first of all, we know when things move, specifically water, they have a tendency to move from a high concentration to a low concentration. And this movement you could also classify as being a movement down a concentration gradient. All right, we've talked about the relationship in our cells with water. All right, so for example, you can see here on the outer part of the cell, there's a higher concentration of water than compared to the inner part of the cell. I got these at different colors, but they're showing the same thing. They're attempting to show water movement. And we know that water wants to move from a higher concentration to a lower concentration. All right, thus there's more water on the outside of the cell and there's less water on the inside of the cell, and the water on the outside wants to move to the inside. Well, what happens when we move across that gradient? All right, when we move across it, now you have things that want to move from the inside of the cell to the outside of the cell. So those components have to move across that water that's coming in. And this can be a challenge. Certain things have to be present for that to take place, and one of the things we've talked about is the sodium-potassium pump. So sometimes energy is needed for certain components on the inside of the cell to move across the material that's coming from the outside in. Okay? So if you were looking for the point in which this relationship takes place, this relationship will take place across the cell membrane. All right, so those two components crossing one another, that point, that region in which that would occur would be along the cellular membrane. So to summarize, since we know that there's more water on the outside compared to what's on the inside, and sometimes things want to move from the inside of the cell to the outside, the point at which those two components would cross one another would be within the cellular membrane. And we know for the components on the inside to make it to the outside, they need something to kickstart that process. And in this case, it would be ATP via the sodium-potassium pump. Okay, looking at this next diagram, we actually can gain a little bit perspective, better perspective of what, if we were just going to identify a term gradient, what a gradient might be. If you see sometimes road construction crews, they construct roads on a grade, and sometimes there's a steeper part of that grade and a lower part of that grade, and that rise or fall is often identified as a gradient. And what's kind of easy to tie into that deals with force, right? So at the bottom part of this gradient, there won't nearly be as much force required compared to what would be needed by the object moving up the gradient midway or to the top. And oftentimes you see these types of signs on highways. This is obviously a little diagram of somebody riding their bike up a gradient. So when you think of that, another good way to identify with gradient is the force associated with it. And if you were to look at this diagram here and see the force needed once again to run up that gradient, obviously as you move up, more force is required at your end because you have things like gravity, you have a higher rate or higher angle of increase in the gradient impacting you as you're running up. So when we're talking about the forces, you can see the force at C of this person running and the force associated with running up that gradient are probably not relevant. They don't interact yet because the individual is not actually interacting with the force associated with running up that grade. B, you would identify B with being maybe a little bit more force, right? So the force of running up the gradient is interrelating to the force associated with going higher and having other forces such as gravity and other components such as that interacting. And you can see at A, that interaction would be greater compared to that at B and C, just because more force would be needed by that individual running and more force is being applied to the individual running through gravity and the actual steepness of the gradient. So another way to identify with that is what we classified in our last analysis. So you have components of your cell, right? And some of those components are positive on the inside. There might be negative on the inside. Some components are positive on the outside. There might be some that are negative on the outside. And when these two interact with one another, you have two different types of forces. Let's take a look at the first one. So for example, if the outside environment was positive and you had some things on the inside of the cell that were also positive that wanted to exit the cell, you would in essence have two forces working against one another. The point at which that relationship would take place in a cell instance would be within the plasma or cellular membrane. So you would have two forces working against one another. And we can relate that once again to the individual running up a steep hill or somebody driving up the steep hill. In this case, you would have two forces working against one another. And at the point they started working against one another, that's the point where you would have the relationship that we've been talking about. In essence, you would have those two forces working against one another across a gradient. All right, and to reflect a gradient or a grade, so some types of incline or decline. So working across that gradient would involve two different forces. The force of this individual running up the gradient and the forces associated that would pull or kind of stop or make that individual work harder to reach the pinnacle of that gradient.